Okay. Hello everyone from Mohit with Less Live Stream channel. And I hope it goes well for you. Today I'm going to teach you another special part which is named Repunits. After that we'll exercise and practice. And besides, we are gonna solve questions rather than lectures. Because of that, I collected different types of questions from different sources. So enjoy it. Let's get started. It is the last part, which means Repunits. Okay, we can start with the definition. A number that contains only ones as digits is called Repunit. Namely, the numbers let me change my marker. Namely, the numbers of the form. It's going to be 1, 1, 1, n times 1. We can write instead of this, that n times 1. If we will convert, we write 10 to the power of n minus 1 over 9. Give a look at the example 111. There are 3 ones. So we can write instead of that 10 to the power of 3 minus 1 over 9. 10 cubed is 1000 minus 1 over 9. 999 over 9. When we simplify it, we will get 111. Okay? So we can write 10 cubed minus 1 over 9 rather than 111. So n times 1. So we write as 10 to the power of n minus 1 over 9. Okay. As I told you beginning of the video, today we have to practice and exercise a lot rather than lectures. So don't waste of time. We can start to solve the problems. Can I clean it? Okay. Today there are just 4 people. What about others? Do you know something about it? They might be late. Okay. So we can move on a bit slowly, maybe. In the life, sometimes when you delay, the opportunities may be lost. Okay. Let me clean it. Can you show us your solution for yesterday's homework, please? Okay. The end of the video, maybe. Please remind me, okay? So today, we will solve the questions from exercise 5. After that, mixed exercise. And I will finish the lesson. I'm planning it. Okay, the first question. Let me write the first one. Prove that prove that 1, 1, 1, n times 1, and after that 2, 2, n times 2 is repeating, can be written as the product of two consecutive natural numbers. Can be written as the product of two consecutive natural numbers. Yes, very good. Difference between consecutive natural numbers, it's a 1, so we can take as n and n plus 1 for consecutive. Before solve it, let me give you one simple example to understand better. (1,122). When we separate it with the Repunits, we can write 1, 1, 1, and 1. 1,111, right? Plus 11. When we take sum of the numbers, we will get 1,122. So actually 1,122 is 10 to the power of, there are 4 ones, 10 to the power of 4 minus 1 over 9. And here 11 is 10 squared minus 1 over 9. So 1,122 will be 10 to the power of 4 minus 1 over 9 plus 10 squared minus 1 over 9. So instead of this number, we can write 10 to the power of, let me show you with details. It's the same way. Here is 2n, and here we have just n. When we add the numbers, we will get it. So this number equals 10 to the power of 2n minus 1 over 9 plus this number is 10 to the power of n minus 1 over 9. Right? Yes. If 10 to the power of n is a, it will be a square minus 1 plus a minus 1 over 9 is equal to a squared plus a minus 2 over 9. When we factorize it, we will get a plus 2 times a minus 1 over 3 times 3. Is there any relationship between these numbers, a plus 2 over 3 and a minus 1 over 3? Look at it. I'm giving you this. Actually, a minus 1 over 3 times a minus 1 over 3 plus 1. Instead of a plus 2 over 3, we can write a minus 1 over 3 plus 1. So these two numbers are consecutive natural numbers. Okay, did you understand? Okay. Can we look at the next question? Or you are still writing? Or as always, you will say just yes or go to continue? Continue. The others, do you agree with that? So we can continue. Okay. Second question. Prove that 1, 1, 1, 2n times 1 minus 2, 2, 2, n times 2 is a perfect square. A perfect square. We have to prove that. Let me give you a time to think and absorb the question. At least you can do something for that. So a couple of minutes you can think about this. Good morning, Mr. Rajai. Thank you very much. When we compare today, yesterday, and before yesterday, there are less people, Mr. Rajai. Maybe they are not informed, or they might be late. Maybe, I don't know. Okay, anyway, let's start it. One, 2 n times 1 will be 10 to the 2 n minus 1 over 9. And instead of n times 2 here is repeating, we can write 2 times 1, 1, 1, n times 1, which is 2 times 10 to the power of n minus 1 over 9. And we will take difference between numbers. 10 to the power of 2n minus 1 over 9 minus 2 times 10 to the power of n minus 1 over 9. And we have to prove it's a perfect square. If we say 10 to the power of n is equal to a, it will be a square minus 1 over 9, 10 to the power of n square, 10 to the power of n is a, so it's going to be a square minus 1 over 9 minus 2 times a minus 1 over 9 is equal to a square minus 1 over 9. We have a common denominator, so we don't need to equalize it. Let me write just 9. And minus 2 times a minus 2a. Minus 2 times minus 1 is plus 2 is equal to a square minus 2a plus 1 over 9. A square minus 2a plus 1. A minus 1 square and 9 is 3 square. So instead of that, we can write with the common power a minus 1 over 3 to the power of 2. As you see here, difference between these two numbers is a perfect square. A minus 1 over 3 square. Actually, it is 10 to the power of n minus 1 over 3 square. Is there any problem here? Everything is all right? Can I clean it? Give me the signal. Okay, question 3. And by the way, after number theory, after our lesson, you will have algebraic expression lessons. And it starts, I think, at 11, okay? At around 11. So be on time. Find the smallest. Find the smallest. N is element of natural number such that one n times 1 is divisible by 13. Is divisible by 13. We have to find smallest value of n. And n is element of natural number. And again, we have Repunit number, n times 1. Thirteen is a prime number, so let me give you a clue, hint. 13 is a prime number, and this number is divisible by a prime number. Generally, for the divisible by prime numbers, I give you two special theorems, such as Fermat-Little theorem and Fermat theorem. You can apply one of them, or maybe both. So try to do something, please. 13 divides this number. N is equal to 12, yes. So we have to use Fermat's little theorem, right? Remember, a to the power of p minus 1 is congruent. 1 here is remainder in mod p. So we can say that by using Fermat's little theorem, ten to the power of 12 is congruent 1 in mod 13 by using this. And we know that n times 1 here it will be 10 to the power of n minus 1 over 9. If n to the power of n is divisible by 13, we will get here as also another 1. So how can we get rid of it? For n is 12. 10 to the power of 12 divided by 13, remainder is 1. So 1 minus 1 is 0. 0 over 9 is 0. And by the way, the number can be divisible by 13. But 12 is the smallest number for n. In this case, we have to find divisors of 12. And after that, for each divisor of 12, we have to check it. For example, to find factors of 12 is 2, is 3, it's 4, and it's 6. We got 12, okay, no problem. 10 to the power of 12 divided by 13 is the remainder is 1, but 12 is the smallest. We have to control it. So how can we figure out? By finding divisor of 12. So for n is 2. 10 square is congruent in mod 13. What is it? 10 square is 100. Divided by 13. 13 goes 100 how many times? 7 times. So we will get is 91 and remainder is 9, right? Yes, it's 9. We can find for n is 3, for n is 4, and for n is 6. When we use for n is 6, also we will get for 10 to the power of 6 is congruent 1 in mod 13. So instead of 12, actually we can use 6. 6 is the smallest natural number. So let me summarize in this such a way. 13 is divisible n times 1. Yes. The number is divisible by 13. So we have two steps. First, we found n as a 12, and after that we found divisors of 12, and we checked all factors in mod 13 by using modular arithmetic system, and finally we got for n as 6. Okay. By the way, we have finished exercise 5, so now we will begin mixed exercise. It will be a general review for us. So in this case, we'll remember other days, first and the second day, by solving these problems. And I hope you will enjoy it. Can we start mixed exercise? Let's start it. Mixed exercise. The first question. Prove that if K divides AE plus B and K divides the same K, it is lower case, okay, K CE plus D, then AD minus BC is divisible by K. We have to prove that. We have to prove that. I think to solve it, we have to go back on time. Just remember, if first day of the lesson, if D divides N, when we multiply N by any number, let's say by A, still AN is divisible by D, right? For M, BM is divisible by D. So when we take sum and difference of the numbers, Still, these numbers are divisible by d. So an plus bm and an minus bm still divisible by d. Yes. So we will do the same thing actually. We will use the same method. So I will multiply the first expression by c, yes, and the second expression by a, and after that, yes, Oliver, as you said that, we will take difference between numbers. So first multiply the first number by c. Why we will multiply by c? Because ae and ce, look at the numbers ae and ce. To get rid of these numbers, we will multiply the first number by c and the second by a. And after that, we will take difference between these numbers. Okay. So k divides ae plus b. When we multiply ae plus b by c, still k divides ae plus b times c. And we will multiply the second number by a. So k divides ce plus d and multiply ce plus d by a. And still the number ce plus d times a is divisible by k. And after that, we will take difference. K divides ae times c is ace plus bc. And k divides a times ce is ace plus ad. We have to find AD minus BC, so I will take the second number first. So K divides ACE plus AD minus ACE plus BC will be ACE plus AD minus ACE minus BC. ACE and ACE cancels each other out, so we will get just AD minus BC. By the way, we proved that. It's proven. Is there anybody problem here? Did you get the point? Okay, let me write the second one. Determine a 4-digit number ABCD. If ABCD, 4-digit number, okay. And CDA, 3-digit number, minus ABC is equal to 297. And here is also given A plus B plus C. 27, which means A is not element of 0 and C is not element of 0 equal to 0. And C is not equal to 0, yes. So let me read the question. If ABCD is a digit number and CDA minus ABC given 297, and the sum of A, B, and C is 27, but here is A and C is not equal to 0. We have to determine 4-digit number. Determine it for find ABCD. Yes. Find ABCD. Okay. If we open ABCD, we will get 1000A plus 100B plus 10C plus D, but instead of that, actually CDA minus ABC is given 297. We can start from here. So we'll open CDA as 100C plus 10D plus A minus ABC will be 100A plus 10B plus C, which is 297. Yes. And let me write directly. I will simplify it. We will get 99 times C minus A plus 10 times D minus B is equal to 297. So if we say C minus A is X and D minus B is Y, so we can change it. We can write instead of that 99 times 6 plus 10 times Y is equal to 297. So C minus A can be represented by X and D minus B represented by Y. So the question will be 99 times X plus 10 times Y is equal to 297. First, we can find the value of X and Y. So it's obvious that X is 3, Y is 0. So in this case, C minus A is equal to 3, D minus B is equal to 0, which means D is equal to B. Yes, we got it. It is the first step. The second. And after that, we know that A plus B plus C is equal to 23, and A and C is not equal to 0. Instead of C, we can write A plus 3. C is equal to A plus 3. So it will be A plus B plus C is A plus 3 is equal to 23. So 2A plus B is equal to 20. I'm sorry, it's 23 says. Let me check it. Sorry, it's my mistake. It must be 23. Fix it. Yeah. A plus B plus A plus 3 is equal to 23. So we will get 2A plus B is equal to 20. Yes. And by the way, A, B, C, and D is less than or equal to 9, right? 2A plus B is equal to 20 means that twenty is divisible by 2A and B. If 20 is divisible by 2A and B, for A is, we can take even or odd number, but for B is, we cannot take odd number because if B is odd number, 20 minus odd number, I will take B right side. 20 minus odd number will be odd number. For 2A, we cannot get here is natural number. We will get here the fraction for A. So that's a contradiction. The numbers must be digits. So B is even number. B is less than or equal to 8. If B is less than or equal to 8, for B is 8, A is 6, C is 9, D is also 8 because D is equal to B. For B is 6, A is 7, but C is 10. And notice that A, B, C, D is less than or equal to 9, so I have to cancel this part. For B is equal to 6. For B is 4. For B is 4. 8 is 8. If 8, A is 8, C is 11. It's also a contradiction. So there's only one solution for A, B, C, D. It will be 6,898. That's our number. Okay? Okay, the next question is going to be 3. At least I can clean the first step. Maybe you are still writing the second one. X, Y, Z is element of integers. And 6 divides X plus Y plus Z. Then prove that X cubed plus Y cubed plus Z cubed is divisible by 6. Yeah, we have to prove it. When we say if X cubed plus Y cubed plus Z cubed divisible by 6, also when we take difference between numbers, minus X plus Y plus Z, still the number is divisible by 6, right? If it is not, that's a contradiction, so we cannot prove it. So first, we'll start with if 6 divides X cubed plus Y cubed plus Z cubed, okay? And 6 divides X cubed minus X plus Y cubed minus Y plus Z cubed minus Z. 6 divides X cubed minus X is the common factor, X times X square minus 1 plus Y times Y square minus 1 plus Z times Z square minus 1. So 6 divides x times x squared minus 1 is difference of two squares. Remember, a squared minus 1 square. X squared minus 1 square will be x minus 1 times x plus 1. So x minus 1 times x plus 1 plus y times y minus 1 times y plus 1 z times z minus 1 times z plus 1. And after that we can order the numbers. 6 divides x minus 1 times x plus 1 plus y times, y minus 1 times y times y plus 1 and z minus 1 times z plus 1. Okay. So actually we got here is three consecutive natural numbers. The first consecutive part, it is the second one, and it is the third one. So first analyze the first one. We don't need to analyze second and the third because it's the same. I mean that they are also consecutive, three consecutive natural numbers. So look at the first one. X minus 1 times x plus 1. Three consecutive natural numbers. As you remember that for three consecutive natural numbers, one of them must be divisible by 3, right? We have done this before, remember. So automatically, here is x minus 1 times x plus 1 is divisible by 3. So for three consecutive numbers, always we will get two even numbers. For example, 6, 7, 8, 6 and 8 even. 10, 11, 12, 10 and 12 even numbers. So automatically, for three consecutive natural numbers, we can say they are divisible by 2 as well. Okay? So automatically, 6 divides x minus 1 times x plus 1. Also 6 divides y minus 1 times y plus 1. For z is same. Z minus 1 times z plus 1. Okay, glad to have it. We got the solution. It was another special question, by the way. Okay. Do you have any problem here? I think it doesn't become more complicated for you. Because here is, I tried to simplify it. If you didn't understand, I can explain the steps again for you. Okay, question 4 is coming. N is element of natural numbers. 101 divides n squared plus 8n minus 85. How many different n values are there? How many different n values are there? Okay. If you don't mind, can I clean the solution? Today you look a bit sleepy. Kiki, yes, okay. And others? Okay, Angela, yes. Blagoyca, yes. Okay, let me clean it. Okay. So n plus 8n minus 85 is divisible by 101, and n is less than or equal to 1000. N is element of natural numbers. And how many different n values are there here? So first we will start from here. From n squared plus 8n minus 85 is divisible by 101. I will separate n squared plus 8n minus 85 such as n squared plus 8n plus 16 minus 100, because I will try to get here a perfect square. N squared plus 8n plus 6, what is it? N plus 4 square minus 100, right? And by the way, we got here is 100. Can you see this? So here, the most important part, separate 85. Instead of negative 85, we wrote plus 16 minus 101. So the question will be now, n plus 4 squared minus 101 is divisible by 101. Okay. 101 divides n plus 4 squared minus 101. Okay. So, 101 is divisible by 101. And remember, so n plus 4 squared also must be divisible by 101. And moreover, n plus 4 is divisible by 101. So 101 divides, and n plus 4 must be divisible by 101. So we can say, when we divide n plus 4 by 101, what is the quotient? Let's say k. So when we multiply n plus 4 and the k, we will get 101. So 101 is equal to n plus 4 times k. Or 101 times k is equal to n plus 4. Right? Because here is, we don't need to multiply n plus 4 by k. Instead of, we can use just 101 times k, because when we divide n plus 4 by 101, the answer is the k. So n plus 1, n plus 4 is equal to 101 and k. Okay, so can you hear me? Hello? Okay. Eva says it stopped for me. What's happened, Eva? Everything is all right? Everybody? Now we are missing 4 people. We have just 6. Can you repeat from n is equal to 100 and k minus 4? Okay, first write it and after that I will repeat everything here, okay? Okay, I will explain again, no problem. I will repeat it. So I will take from here, from n plus 4 is equal to 101k. Okay, so when we isolate n, we will get 101k minus 4, and which is n is less than or equal to 1000, so we can take values for k. We can start from 1, 2, we can go till 9, because for k is 10, n will be greater than 1000, so that's a contradiction. We cannot do this. From 1 to 9, we can take all values for k, all natural numbers from 1 to 9. For k is 9 different values, for n is also 9 different values. So for n, we have 9 different numbers actually, such as 97, 198, till 905. Between 97 and 905, you can find the other numbers by using value of k, okay? So let's go for question 5. Eva, did you understand? And others? Don't mention it. Find the natural number n if n square is equal to, if n square is equal to it is 1994 times the end we have 5 times 1995 times 1s plus 1. Yes. It's a mathematical language. When we multiply these two numbers and after it when we add 1, we will get here is a perfect square, n squared. So we have to find the value of n. And by the way, n is a natural number. I'll try to do something. I want you to do something here, really. Here is 0 repeating and here we have 1 is repeating. 0 repeating 1994 times and 1 is repeating here 1995 times. We will take product of these two numbers. After that at 1 will give us n squared. We have to find n here. Okay, where can we start it? So first tell me 1005 is 1000 plus 5, right? Do you agree with that? Yes, no problem. I think you are not against it. So we can write this number instead of this number, instead of that one, we can write, but 0 is repeating 1995 times because also we have to here instead of 5 write 0 and plus 5. Five is not clear. Let me write again. And 5 will give us 1994 times 0 and 5. Okay? So this number is 10 to the power of 1995, right? This. And here we have 1. When we add these numbers, we will get 10 to the power of 1995 plus 5. Yes. It is the first step. The second step is 1, 1, 1. How many ones? 1995. So it will be 10 to the power of 1995 minus 1 over 9, right? Remember. 1 n times 1. What is it? 10 to the power of n minus 1 over 9. So it will be 10 to the power of 1995 minus 1 over 9. So it is the second step. So we can go for final. So the number will be here is 10 to the power of 1995 plus 5 times 10 to the power of 1995 minus 1 over 9 plus 1. If, let me write here. If 10 to the power of 1995 is k, by the way, this number is equal to n square, right? We will get here, I will write directly a k plus 5 times k minus 1 over 9 plus 1. When we multiply, after that factorize, simplify, and plus 1, we will get for n square k plus 2 over 3 square is equal to n square. So k plus 2 over 3 is equal to n. Yes, k plus 2 over 3 is equal to n. So which means 10 to the power of 1995 plus 2 over 3 it is. But as a repeating, how can we write it? Let me take one simple example for that. Example. Brainstorm. By the way, 10 to the power of 1995 plus 1 will be is 1994 times 0, and finally is 2 over 3. It will be 3, 3, 3. How many times 3 is 1994? And finally, we will get here. For of course you didn't understand. I will clear it. First, write the solution. I want to explain with simple example. Okay, how can we do this? First, copy everything, and after that, I'll give you one simple example. Okay, let's write it. Have you done? Okay. I will try to explain with simple example, as I told you before. Now look at it. 10,002 over 3. Okay. What is the answer here? 3,334, right? Yes. The number of 0 here is 3. It's also 3, the number of 3's. 11 over 3 is 4. So when we go back our question, it was 1,994 zeros over 3. The same thing is 3, 3, 3. How many times? 1,994 times repeating. And 11 over 3 is 4. Okay? That's the mathematic. I have got one last question, and after that I will solve Eva's problem from yesterday, the fourth one. Okay? Question 6. If the natural number n is divisible by 4, number n is divisible by 4, then prove that 1 to the power of n plus 2 to the power of n plus 3 to the power of n plus 4 to the power of n is divisible by 5 as well. We have to prove that. Do you have any idea about it? How can we solve it? How should our approach be? How can we figure out? We will use here the algebraic expressions, or by 5, divisible by 5. N is divisible by 4. The number is divisible by 5. Here is 4. N is divisible by 4. Seems very complicated, right? Very, very complicated. And time by time, it becomes more and more complicated. I can understand. But it's very easy, actually. We will make it easier. And I hope you will understand. All you need to do is here, remember 8 to the power of n plus b to the power of n. That's it. You are confusing here, right? N is divisible by 4 and the expression is divisible by 5. So you will start from 4 divides n, N is for k. K is odd number, even number. For odd number, 2L plus 1 we can take, but it's not necessary. Leave out all the rest. Instead of that, a to the power of n plus b to the power of n. A plus b times k. A to the power of n minus b to the power of n is a minus b times L. So I will make a group. 5 divides 1 to the power of n plus 4 to the power of n plus 2 to the power of n plus 3 to the power of n. So 5 divides 1 plus 4 times k and plus 2 plus 3 times L. So 5 divides 5k plus 5L. So finally 5 times k plus L is divisible by 5. That's enough. We got the solution. Okay. You don't need to do anything here. Okay. Just remember a to the power of n plus b to the power of n. In conclusion, actually, for n, we can use any natural numbers. For example, 1, 2, 3, 4, 5, go till plus infinity. No matter what, the expression is divisible by 5 because by using a to the power of n plus b to the power of n, we can prove it. It's proven. 5k plus 5L. 5 is a common factor and k plus L. So for any value for n, for any value of n, the expression is divisible by 5. Okay. So the last question is coming from yesterday. It was homework. Let's go for the final question. N square minus 15n plus 55 says is a perfect square is equal to k square, and which is n is greater than 9 and n is element of natural numbers. Find all n. Yes, find all n. Did you get something here? If n square minus 15n plus 55 is equal to k square, is it perfect? So n square minus 15n plus 55 can be negative number? Can be negative? For example, minus 2 is equal to k square. What is k? Is it perfect square cannot be never negative, right? So n square minus 15n plus 55 is a positive. Means that n square minus 15n plus 55 is greater than or equal to 0. So if n square minus 15n plus 55 is greater than or equal to 0, n square minus 15n is greater than or equal to minus 55. N is greater than 9, so we can start with 10. For n is 10, it will be 10 square minus 15 times 10 is greater than or equal to 0, right? Yeah, it is 0. I mean that 10 square minus 15 times 10 is a negative 55. For n is 10, 10 square minus 15 times 10. 10 square is 100, minus 150 is greater than or equal to minus 55. So minus 50 is greater than or equal to minus 55. It provides, but for 10 is 11 and the other numbers which is greater than 10, n square minus 15n is less than negative 55, so that's contradiction. That's contradiction. So we have just only one solution. Only one solution. And what is it? N is 10. 10 square 100 minus 15 times n 150. 100 minus 150 negative 55 plus 55 is 0. So k will be here is 0, which means k is a perfect square. Okay? That's over. We finished the lesson. Last but not least, I wish to say that be happy. Just be happy. If not, try to be happy. And don't forget it, try to be happy in your head, in your hand. Don't forget it. Bye bye, math lovers. Have a nice day, have a nice weekend. I wish you every happiness and success. Goodbye.